Now we're working on 2.5, an introduction to problem solving. So I picked out 3 problems from the Chapter 2 review that can be found on page 205 in your textbook. We're going to look at problems 46, 48, and 52. 46. 6 times a number decreased by 20 is 4 times the number. Find the number. So again, this is a problem where I need to focus on translating English to math. So let's read it again. And as I'm reading it, I'm going to write it in my math language. 6 times a number, well, 6 times means multiply. A number, well, I don't know what the number is, so I'm just going to call it y. So 6 times a number, decrease by, well, decrease by means subtract, 20. Decrease by 20 is, well, is means equal, 4 times, well, again, 4 times means multiply, the number, well, it's the same number, so it's again going to be y. So 6 times the number, decreased by 20, is 4 times the number. So I end up with 6y minus 20 equals 4y. And then it says find the number. Okay, so how do I find the number? I just need to solve this equation for y, which is my unknown variable. So let's see here. Let's see. I have 6y minus 20 equals 4y. Let me get a different color pen. Red. Alright, so the first thing I need to do is get my variables together on one side. And in order to do that, I'm going to move the one with the smallest coefficient. That's what I normally do. But what do you notice? I have the minus 20 already on the left side. So I'm better off just moving the 6y over to the right. So if it's a positive 6y, how do you move it? Subtract 6y on both sides. And you get negative 20 equals negative 2y. Good. One second. Okay. So now I have negative 20 equals negative 2y. I still got to solve for y, so how do you move a negative 2? That's multiplying. You divide, so divide by negative 2. And you end up with y equals positive 10. And again, you can plug it back into this equation and see if it works. Now that's assuming that you wrote this equation correctly. Awesome, so that's 46. That's talking about translating from English into math and then solving like we've been doing since the beginning of chapter 2. Now problem 48, let's look at it. 1 second. Oh, what is this? No, go away. 1 second. Oh, 1 more second. Okay, 48. 2 pages that face each other in a book have 93 as their sum. I'm sorry, let's read that again. 2 pages that face each other in a book have 93 as the sum of their page numbers. What are the page numbers? So there's 2 pages in the book, and they face each other. And if I take their pages and add them together, so that's what sum means, if I take their pages and add them together, I should get 93. Alright, so let's think about this. Let's use an example. So here's the example. I'm going to draw a book. It's a horrible book, but you know, you'll go with it. And these are 2 pages that face each other. And let's pretend like this is page number 2, which means this will have to be page number 3, because it's the next page. So if I called the first page X, the second page will have to be X plus 1. Do you see how we did that? X, which means the next page has to be X plus 1. So if I say the sum of the 2 pages, so the sum of these 2 pages means I'm going to have X plus X plus 1. And what does that have to equal? 93. The sum of the 2 pages have to equal 93. Now let's solve for X. And how do you do that? Well, first you got to simplify. I gotta get my like terms together. I have x plus x, which is going to be 2x. So I have 2x plus 1 equals 93. Now I need to isolate x. And who's in x's territory? Well, there's a 2 and there's a positive 1. Let's move the positive 1 first. And how do I move something that's adding? I'm going to subtract. So subtract 1 on both sides of the equal sign. And you get 2x equals 92. Now I still got to isolate x. And there's a 2 hanging out here. So how am I going to move the 2 that's multiplying? By dividing. So I'm going to divide by 2. And you end up with x equals 46. So one of the page numbers 46, which means x plus 1. The other page has to be 47. Okay, so let's work on problem number 52 from 2.5, still on page 205. A rectangular field is 3 times as long as it is wide. If the perimeter of the field is 400 yards, what are the field's dimensions? So this is a problem-solving problem, like all of them are. And with this one, we're going to work through the 4 steps that we talked about before. Step 1 was to figure out, well, what are they looking for? Why does this keep coming up? Let's see. Thank you. Sorry about that. Where was I? Step 1 was to figure out, well, what are they looking for? They're looking for the dimensions of the field, and it's a rectangular field, so they're looking for the length and the width. So I'm looking for the length, question mark, width, question mark. Those are what I'm looking for. Step 2 says, well, what was given to you? Well, they told me some information. They said a rectangular field, so I'm going to draw this rectangular field. And you can pretend like that's a rectangle. And if you don't believe it, well, I'll label it rectangle. A rectangular field is 3 times as long as it is wide. So that basically means the length is equal to 3w. 3 times as long as it is wide. So if the width was 2 yards, the length would have to be 3 times that, which would be 6. Okay, so they gave me that. And then they said the perimeter is 400 yards. So P, perimeter, is 400 yards. Now really I should make a little key and tell you what my variables are, right? So L is going to be the length, W is the width, and P is the perimeter. It's very good, always good to label and let people know what you're talking about, even though I use an L, W, and a P. Awesome. So that's all the information they gave me. Then step 3 was, well, what's inside your toolbox? What do you know? This is a rectangle, and we're talking about perimeter. Let me label this rectangle. Let this be length, and let this side be width. All right, so this is a rectangle, and I'm talking about perimeter. Well, what's the perimeter of a rectangle? So perimeter, what's the formula? It's going to be 2 times the length, because there's 2 of them, right? The length is also up here, plus 2 times the width, because again, the width is right here. And perimeter means add up all the sides around, the total distance around the field. So I have length plus width plus length plus width, also known as 2 length plus 2 width. Good. And then step 4 says, well, let's answer the question. All right, so I'm going to start filling this in. I'm going to use this formula that I got in my step 3. So the perimeter, instead of writing a P, let me change my color. Instead of writing P, now I'm going to write 400. So this is 400 equals 2 times, but instead of writing L, they told me something. The length is equal to 3W. As they said it, a rectangular field is 3 times as long as it is wide. So instead of writing an L, we're going to write 3W plus 2W. So now I took this equation that had 1, 2, 3 unknowns and turned it into an equation with only 1 unknown, and I can solve for W. So let's simplify. So I have 400 equals 6W plus 2w. And on the right side, I have like terms, so let's put them together. So I still have 400 equals 6w plus 2w is 8w. All right, so now I need to isolate w, but 8 and w are multiplying together, which means I'm going to divide by 8. And I end up with w equals 50 yards. So I answered the width question, which means now I got to answer the length. And let's go back to this equation. We said length was equal to 3w. So length equals 3 times w, which is 50, which means length must be 150 yards. Make sure you're practicing these problems that require you to do a few steps to get the final answer, especially ones that talk about fields and perimeter and area.